Welcome to our math for today. We're going to take this really slow. This lesson we're going to break up into probably 2, maybe even 3 days. Okay, so we're looking at theoretical and experimental probabilities. So Rowan and Kaylee are designing a nutrition game for their health class. They need to find a way for players to select a number from 0 to 9 randomly. Rowan suggests they use the last digits of food prices and store flyers. Kaylee and Rowan wonder if the digits are random. Okay, you're not going to need a spinner or a blocks in a bag. Okay, so let's get to this. So, do the numbers 0 to 9 appear with equal probability in different place values in food prices? So, part A. Suppose the numbers 0 to 9 were equally likely in the last digit of a food price. What is the theoretical probability of having each number 0 to 9 as the last digit? So remember, theoretical probability is what should happen. Experimental is when you actually do an experiment. Okay, so I'm helping you out here. There are 10 different numbers, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. What's the probability if it was equally likely? Okay, so pause it and see if you can calculate that probability. Remember, we want a percentage. Okay, so I'm hoping you figured out that each number has 1 out of 10. So it's a 10% chance for the last digit to be any given number. Okay, so if it was equally likely, it would be a 1 in 10 chance that it would be a 9, or a 1 in 10 chance that you'd have an 8 or a 5. Okay, looking down our list here, we kind of see that that's not the case. All right. B, record the frequency of each number 0 to 9 as the last digit in the list of food prices shown. Calculate the experimental probability. So theoretical is where you calculate what should happen. Experimental is when you actually get the numbers. So we can see a list of groceries and you can see their prices. So this is now experimental because you can actually do some math with this. Okay, so what I want you to do, I want you to make a tally chart. Looks just like this, 1 through 9, and list off all these numbers. Okay, doing it from here is probably not the best. I also uploaded this picture to the lesson as well. Okay, so you might want to stop and actually go to the picture, like get your tally chart drawn, refer to the picture you have. There are 43 of them, I believe. So pause it and make your tally chart, see what you got. You did your tallies. There were 4 zeros, there were 0 ones, there were 2 twos, there were 0 3s, 0 4s, 6 5s, 2 6s, 7 7s, 2 8s, and 20 number 9s. Okay. Calculate the experimental probability of each number. Okay, so what we have to do, I've made this bigger. I've done the first one for you. So zeros, there were 4 out of 43, so I convert that into a percentage because all probabilities are percentages. So 4 divided by 43 times 100 gives me 9%. Okay, see if you can do that with the other ones. So pause it and calculate all the probabilities, please. What you should have, 905 00 14 5 16 5 and 47. So they're the experimental probabilities. D, compare the theoretical that you calculated in step A with the experimental. Is this what you expected? Well, coming back here, we realize that if it was random and it was equally likely that the last digit should, you know, if I've got 10 numbers, I should have like 4 or 5 of each of them, but that's clearly not the case. Definitely 9, 7, and 5 are the 3 most common ones that we see. If we apply this more to Canada, since the rounding happened, the rounding of the pennies, that was actually after this book was made, we'd realize we actually see more 8s. And we do see quite a few 4s these days as well, because a lot of numbers, when you add tax on 4, it becomes a number that ends up getting rounded up. It's kind of an interesting fact. So you'd see that 0 is close to the probability, but the rest of the numbers really aren't. Like 5 is not too far away, 7 is getting towards double, 9 is not even close. You can clearly see that numbers are, the final digit is not random whatsoever. Okay? Is this what you expect? Probably. Okay, so I'm going to leave you for the rest of this math to do E, F, and G. So you're going to be looking at the middle numbers and actually the first numbers as well. Okay, so you're doing the other place values. So you're doing the dollar, and then you're doing the 10-cent place values. You'd probably realize that the first place value, like depending on the item, you'd expect it to be more spread. Okay, depending where you're shopping. If it's a dollar store, you'd expect a lot of smaller numbers. Okay, so the rest of your work for today, and it's probably going to take you a good 20-25 minutes. You basically, we've calculated the third column, the probabilities right here. You're going to be doing the probabilities of the middle column and the first column as well, and then see if you see any patterns. Okay, how do the probabilities for A compare? And then we go from there. So finally, G, do all the numbers from 0 to 9 appear with equal probability in each position in the food prices. You can probably get a guess of that just by looking at it. But your job for the rest of math today is to do E, F, and G. So you're basically doing the same thing as what we did together, but with the other 2 place values. So snap a picture and get your 2 XP for doing that.